learn to find the slope in an algebraic way. Last class, we've been finding the slope by relying on a graph. Today, we will find the slope with a formula. The slope formula is y2 minus y1 over x2 minus x1. Slope formula comes from rise over run. Change in y is going to be the rise. Change in x is going to be the run. Whenever we are finding slope with slope formula, first thing is to label your points, x1, y1, x2, y2. Then we will substitute the points into the formula. Also, we will solve to find the m. The reason why we need to use slope formula is that not every point will be able to easily graph, and we may not be able to use graph for some points to find the slope. For example, if I were to have 2 points, 30, 45, another 2 points, 91, 92. I will have to label each of them my x1, y1, x2, y2 in order to use a graph, and you will have to have a huge graph. To find the slope, you will have to rely on a very large graph, and you may not be able to find accurate points to calculate your rise over run visually. That's one of the reasons why we learn how to find the slope algebraically. Another crazy slope example would be if I were to try to find 0.25 and 0.75, that's one of my points, and if the other point is 1 and 2, we won't be able to accurately determine the amount of rise and the amount of run by just looking at the graph visually, so we would need an algebraic way to find the slope algebraically. Here is a quick review of last class. Whenever we were finding the slope, we will first choose a point, then we will rise and then run to find the next point. We would write the rise as your y value and then write the run as your x value. On the first example here, our rise would be 3 units, run would be 4 units. So 3 to 4, slope would be 3 over 4. On our next example, our rise from this point to this point is going to be positive 4 units. Run would be left 5. I will write left 5 as negative 5. My slope would be 4 over negative 5. Or I can write it negative 4 over 5. We also looked at something called positive and negative slopes. Let's review that quickly as well. A positive slope is a slope that increases left to right. A negative slope decreases left to right. Please pay attention to the fact that I am always going left to right, and then we have a positive slope increases left to right and negative slope decreases left to right. Next, we have a zero slope. Zero slope is not increasing or decreasing, staying same. Undefined slope is a vertical line that goes up and down. We call these kind of situations HOY and VUX last class. We will continue using HOY and VUXes throughout this unit. Now let's find the slope by just using the slope formula. Our slope formula, m is equal to y2 minus y1 change in y over x2 minus x1. Each of these are ordered pairs. Each ordered pair has an x component and y component. Here's my x and then y. Because we have another x and y, we will label them. The first x, second x. First y, second y. Now I will have to substitute these into my slope formula so I can find what the slope is equal to. y2 was 8, y1 was 5, divided by x2 was 4, x1 was 3. Simplify numerator and denominator separately. We will have 3 over 1, which I can just write 3 as my final slope. Here's my second example. I would recommend writing this slope formula each time until you learn the slope formula very well. I will write my slope formula, label my points, x1, y1, x2, y2, then we will just substitute 7 minus 6 divided by negative 3 minus negative 3. Subtracting a negative is addition, so on the numerator I will have 1, on the denominator I have negative 3 plus 3, which will turn into 1 over 0. Because we cannot divide by 0, the result is going to be undefined. Here's our next example. Just like the previous ones, I will first write my slope formula. y2 minus y1 over x2 minus x1. Change in y over change in x. I will label my parts x1, y1, x2, y2. Now we will substitute everything. We will have slope is equal to 10 minus 10 divided by negative 13 minus 6, which will become 0 over negative 19. 0 divided by any number is 0, so our answer is going to be 0 slope. Here's our next example of this type. I will write my slope formula. M is equal to y2 minus y1 over x2 minus x1. Then I will label my points again. Here's my x1, y1, x2, y2. Substitute them into the formula. Negative 20 minus 8 divided by negative 12 minus negative 6. Numerator will become negative 28. Denominator will become negative 12 plus 6, which will turn into negative 28 divided by negative 6. And negative divided by negative will be positive. I can simplify both numerator and denominator by negative 2. Then our slope will turn into positive 14 over positive 3. This is a good example of why we need to find the slope with the slope formula and not just with a graph. In order to find this slope, you will have to go 14 units up and 3 units over to find a nice integer coordinate. Instead of a joke today, I want to introduce Mr. Slope Guy to you. And Mr. Slope Guy has a positive slope, a negative slope, undefined slope, and 0 slope. On your papers, if you draw Mr. Slope Guy somewhere, we will know that you watched your videos. Let's look into finding the slope from a given graph. Whenever we are finding slope from a given graph, you will try to find points that have integer coordinates. I wouldn't choose a point here where I don't know where the y value is, or a point here where x, y value would be complicated. I will try to choose integer coordinates. After choosing the first one, and I'll look for other integer coordinates, you can either go up or down to find integer coordinates. Now I can see my rise over run. It's going to be 1 over 3. This is how we can find the slope of a given line. You will choose at least 2 points with integer coordinates. Our next example uses the same pattern. Choose couple points, integer coordinates. Rise over run, in this case we are going down n over. This would be down 1 over 1, which is equal to negative 1. Now, what would happen if you were to choose a point here and another point here? We will still follow the same pattern. Down 4 over 4 would be negative 4 over 4, which is still equal to negative 1. So regardless of which set of points you choose, you should end up with same slope, because all these points are on the same line. When I see a vertical line, I should remember this is a special case which we will call it the VUX. We call the VUX case because we have a vertical line. On a VUX case, you will have a vertical line, and your vertical line will have undefined slope. Also, equation of the vertical line will be x is equal to 2 in this case, because the value in here, x value in here is 2. Is the equation of the line. So a VUX case is a vertical line, undefined slope, where x is equal to a number is the equation of the line. This will work for every vertical line. For the slope, I will just write undefined. If you see a horizontal line, then it's a HOY case. A HOY case happens when you have a horizontal line and slope of a horizontal line is 0. Equation of a horizontal line is going to be y is equal to a number. In this case, because it's passing through 2, equation is y is equal to 2. Is the equation of the line. Our slope is 0. Let's recap with HOY and VUX again. HOY is for horizontal line. The slope is 0. And y is equal to a number is the equation of the line. Your horizontal line can be anywhere on the graph as long as it's horizontal. This one would be y is equal to negative 3 line. A vertical line requires a VUX case, where we would have a vertical line up and down. Slope of the vertical line is going to be undefined. And the equation is going to be x is equal to a number. Equation of the line. Vertical line will look like going up and down anywhere on the graph, and we will label this one as x is equal to 4 line because it passes through 4. Here's your first try. Try to find the slope with slope formula first, and then graph your points on the coordinate plane to compare your results. Here's your second try. Try to find your slope with the slope formula first, then compare your results by graphing them. Pay attention, it may turn into HOY case or a VUX case. Here's the try 3. You're going to find the slope by just looking at the graph. Try 4. Use your slope formula and then check it by graphing it on the coordinate plane. Here is the last you try. Use your slope formula first, then you can graph. Use your slope formula first, then you can graph. That's pretty much it. If you have any questions, please make sure to bring it to the class.